There are many reasons why some of my projects never get finished. For example,
it was not a good idea. It was beyond my capabilities. Maybe the idea morphed into something else. Maybe I got distracted, or lots of other stuff. However, sometimes projects are stopped because they are too attractive and too alluring, so much so that they become all-consuming. I found this old code on my hard drive today. It was for an Atari 2600 game based on Atari's classic coin-op game, Breakout. I decided to talk about the process of making it and why I stopped making it. It's been about 18 months since I've worked on this game, Brick Basher 2600. I didn't even think about it until today. It's as if I blocked the entire episode out of my mind. I decided to start working on an Atari VCS game back in 2018 because, honestly, it just felt like the right time to do it. It was the first season of Into the Vertical Blank, and I thought maybe an Into the Vertical Blank themed VCS game might be possible. I dreamed of being a programmer for Atari in my youth. Making a homebrew game for the VCS felt like the next best thing. So I downloaded bAtari Basic from its home on GitHub and got started. The first thing I usually do when starting a new platform is to get something up on display, the classic Hello World. This usually involves finding a simple example and swapping out just enough code to customize some small bit, but also allow it to still run without errors. Again, this could be the classic Hello World or anything else really. It just needs to get me over the hump, from mere observer to active participant. I did this with a VCS program called Steve 2. Which was just a simple recoding of the title screen demo that came with the bAtari Basic package. I changed the name of the title screen to Tyler, imagining maybe creating a game about roofing tiles based on the story Clawhammer from this podcast. I wrote a little bit of code for it, but soon realized I had no idea what the game would be about, so I stopped. However, the spark had been lit. The next step was to read the official documentation. For bAtari, those docs are on the Random Terrain website. When I first dove into bAtari, it became clear to me that this basic language is really an Atari VCS compatible game engine that exposes some of the primary features of the hardware without forcing developers to build their own kernel. The kernel in a program for the VCS is the low-level set of code that creates the line-by-line display required by the VCS's TIA chip, television interface adapter. Since the VCS had no memory buffer for holding display information for an entire screen, a feature of nearly all game systems that followed it, each line of display has to be programmed individually in real time. The best Atari VCS programmers know how to wring every last bit of performance out of their custom kernels. bAtari Basic abstracts this from the programmer, providing a multi-purpose kernel that has been made as flexible as possible for certain kinds of games. I decided to stay within the guardrails of bAtari Basic to see what I could make. I was not trying to prove my technical ability. I was trying to be creative and get something accomplished. This is the main draw of languages like bAtari Basic, to allow people to flex their creative muscle while limiting their exposure to the technical underpinnings of the system itself. There are trade-offs, of course. The particular kernel, actually there are several kernels, employed by bAtari Basic might not be suitable for every game. In fact, I figured part of the job of a bAtari Basic programmer is to work within the constraints of a language that itself was built within the constraints of the VCS itself. While I did not want any limitations, at the same time I wanted to create something. But what could be created with the available resources and limitations? I was kind of stumped. I played a lot of VCS games in my day. I started 42 years ago and have pretty much never stopped. I felt it should be innate to me to know what is possible on the VCS and what is not. Was I paying attention the whole time? Was I even capable of doing this? As I read through the bAtari Basic documentation, a creeping realization came over me. While bAtari is an implementation of a kernel for the VCS, it still adheres closely to the features and limitations of the original Atari hardware. Patterns emerged that matched up with my many decades of experience playing games for the console, highlighting certain features and idiosyncrasies of the VCS that I had unconsciously cataloged since I first played it in 1978. Number 1. 128 bytes of RAM. I'd heard for years that the Atari 2600 only had 128 bytes of RAM, but that did not sink in until I started using bAtari Basic. 128 bytes basically means you can track 128 8-bit numbers, or as GCC hardware developer Steve Golson said in a recent interview, 1024 precious bits. Not everything in a game can be represented as true-false, as you might need to track screen, XY locations, scores, lives, etc., and many of those things require a full byte for numerical storage. bAtari Basic is even more restrictive. Of those 128 bytes, only 26 are available for your game because the rest are used by the game engine kernel. You must track everything dynamic in your game with those 26 bytes. Instantly, this removed a whole set of game ideas off the table. This is one of the first big trade-offs you make using bAtari Basic. However, what you gain, to me at least, is still worth the effort. By the way, this also made me realize the power of the 4K of RAM in the Atari 7800 and the 6K of RAM within the Starpath supercharger. All of a sudden I could see how a game like Dragon Stomper, the first console RPG, could only be made with the extra RAM in the supercharger. My eyes were opening. Two, sprites. Sprites are the independent graphics that a game moves on the screen to create players, enemies, shots, etc. Some systems like the VCS and the Atari 800 have what is known as hardware sprites, which means they're built into the system and can be easily manipulated. Other systems, such as the Atari ST, employ what is known as soft sprites or software sprites, which must be defined and controlled completely by a programmer. The Nintendo Entertainment System has 64 sprites that can be defined and manipulated by a programmer. By contrast, the Atari VCS can display 2 sprites, 2 missiles, and 1 ball. That's it. bAtari Basic's default kernel works under these limitations. The language also supports a multi-sprite kernel with 6 sprites and a DPC Plus kernel that can handle 10, both with various other advantages and disadvantages over the default kernel. When displaying sprites in the VCS, there are many options built into the hardware. For example, sprites can be displayed double or quad wide, can also be displayed as multiple copies of themselves. This got me thinking about combat and how biplane and jet game variants of the first game for the VCS allowed for multiple and bigger planes. When I read about the sprite options, a light bulb suddenly turned on. I was learning some basic aspects of how the VCS was actually used to create games. It was obvious that these sprite options were employed to make combat. Furthermore, the double wide option reminded me of the player's paddle in Breakout. When the game starts getting fast, the player's paddle shrinks in size. Could the programmer simply have employed a double wide sprite at the beginning of the game, then switched to a single wide paddle as the difficulty increased? Maybe. Reading the documentation for bAtari Basic was like opening up a whole new world of understanding for me for the Atari VCS. I love discovering these little bits of information that opened up my conceptual knowledge of how the original VCS games were built. Thinking about it further, Video Olympics also uses the ability to create multiple copies of sprites. This would explain how certain versions of Pong on that cartridge allow for multiple rows of paddles controlled by the user. Again, I did not know if these were the methods employed by the original programmer, but it did not matter. I can imagine a way to solve the problem of Video Olympics, and it felt very liberating. Just to confirm my suspicions, I found the Stella programming guide from 1979 online. Famously, Stella was the code name for the VCS, also named after Joe Decure's bicycle. In the guide, I found a chart that described the features of Atari VCS sprite display, and they matched up with what was available in bAtari Basic. In fact, even the names of some of the memory addresses used to set the sprite information, like new size 0 and new size 1, were exactly the same. My instincts were correct. I was seeing the exact same features as the first Atari VCS programmers. Three, colors. When reading about colors, I noticed something that made me think of the first time I played the Atari VCS. As I stated before, the TIA hardware in the VCS allows for 2 player sprites and 2 missiles, one for each player. However, the missiles must be the same color as the player. Reading this gave me a total recall of the first time I played Outlaw on the VCS and wondered why my shots were the same color as my cowboy. It was a very simple thing, but stood out to me, even as an 8-year-old, as being unrealistic and forced me out of the fantasy of the game into the real world. Games like Outlaw were filled with these types of nuances that live directly in the vertical blank, not the real one, the virtual one we talk about in this podcast, and drive me nuts on a daily basis. However, right here, 40 years later, I now had an explanation. The shots had to be the same color, at least using the VCS default capabilities. More secrets of the VCS were unlocked before my eyes. To further this concept of colors, the VCS also has a single ball object, and it must be the same color as the Playfield graphics. More on Playfield graphics later. This made sense to me too. I recalled that the ball in the Video Olympics cartridge was also the same color as the Playfield, and it sometimes got lost among the various obstacles as you were playing. Of course, this was based on hardware limitations. I'm sure there were ways to change this, but not every programmer wants to re-engineer an existing system to make a game. Some just want to create. Since Video Olympics is one of the first VCS games, the programmer, Joe DeCour, most likely employed the default capabilities that were provided by the hardware, and this meant the ball was the same color as the Playfield. To confirm these color limitations, I looked at the Stella Programmer's Guide again, and I found a table that showed exactly this. Colors for the players and missiles were indeed the same, as were those for the ball and the Playfield. In cases like this, bAtari Basic was a direct line into the VCS. This made me feel less like I was cheating using bAtari, and more like I was simply using modern technology to make the chore of building VCS games much easier. Four, the Playfield. The Atari VCS includes a graphic feature called the Playfield. A quick check of the Stella Programmer's Guide showed me that not only is the Playfield a standard feature of VCS hardware, but much like the new size 0 for Sprites, bAtari Basic uses the same names for the memory addresses, PF0, PF1, PF2, as a low-level assembly language program would use to manipulate the Playfield. This was further confirmation to me that the features I was discovering were similar to the ones available to the original VCS programmers. The Playfield is a coarse pixel display area that allows for the creation of mazes and obstacles that, for instance, the player will navigate or stop with missiles. The pixels are really just large blocks displayed at 32 by 11 or 32 by 12, depending on which bAtari Basic kernel you are using. The default bAtari Basic kernel allows you to place Playfield graphics across the entire screen. However, bAtari's multi-sprite kernel has a mirrored Playfield. This idea of a mirrored Playfield is another Atari VCS nuisance that has stuck with me through the decades. The mazes in combat and even the rooms in adventure always struck me as unrealistic because they were completely symmetrical. These symmetrical Playfields make up the background graphics of my Atari memories and are a huge part of what makes up the vertical blank in my head. These Playfield graphics are intriguing because it seems like they could be manipulated in ways that might not have been originally intended. For instance, I always wondered how a game like VCS Surround was made. When I first saw the Playfield graphics, a possible method became apparent to me. The players in Surround were the two player sprites, but their trails were probably Playfield graphics. Furthermore, each individual line of the Playfield can be a different color, and the heights can each be adjusted. As well, bAtari Basic includes a function for turning the Playfield graphics on and off. On and off. Bingo! Turning Playfield graphics on and off seemed like an interesting concept for making a game. After discovering these features and more, ideas for VCS games trickled into my brain. I now had a little bit of insight into how some of the original Atari VCS programmers could have looked at the features and limitations of the VCS hardware and began devising games based on both. In fact, nearly all of the original 9 Atari VCS games released in 1977 used some or all of the features I discovered in the bAtari Basic manual. But what game could I make? The answer came quickly. The fact that Playfield graphics could be turned on and off reminded me of one great game, Breakout. Atari VCS Breakout was my first love when it came to video games, and I felt like my entire life in technology started with that game. It was only natural I would try to recreate it. I started with using the Playfield in the regular kernel so I could plot across the entire screen. By limiting the height of the layers of bricks, rows of Playfield graphics, and expanding the height of the lower lines, it seemed possible to create the rows of bricks required for what was becoming my own version of the classic game, renamed Brick Basher 2600. The biggest breakthrough, no pun intended, came when I figured out some simple code to check to see if the ball had hit one of the bricks. Since collision detection only exists among the player, missiles, and ball, but not of the Playfield, defining when a brick is hit and needs to leave the screen would need to be accomplished with some custom code. Since all the bricks are uniform size, I figured I could write a simple bit of code to see if a ball was currently within the bounding box of a brick. If the brick, a Playfield graphic, was on, it would simply turn off and bounce the ball at an angle, and my job was done. The code came fairly quickly. It was messy and filled with literals, but it worked. The experience was thrilling. My quest was to keep the game under 2K of ROM, because that was a limitation of the earliest Atari VCS programmers. Every time I came up with a coding solution to a problem, I would refactor and refactor again until it was the most economical use of code I could devise. Sometimes features got lost, but as long as the game stayed pretty much like Breakout, I didn't care. I was finally building a game for actual Atari hardware. A lot more than the above items went into making the demo I finally made. Lots of iterations and trade-offs and refactoring went into just getting this far. And I admit the results are still kind of underwhelming. Nothing really works exactly right in my demo, but almost all the features are just on the cusp of being finished. However, I stopped here, and for a good reason. The Atari VCS began consuming all of my downtime. I found myself thinking in terms of the VCS all day and night. One fateful day, in early December 2018, while driving to pick up one of my kids, I recall my mind wandering to the game Canyon Bomber. I was trying to remember exactly how it was played, and more importantly, if a game could be recreated with a similar playfield block strategy as my Brick Basher game. I was so consumed with the sudden idea about the VCS that I forgot I was driving. I ran a red light and nearly got into an accident. This was my wake-up call. Sure, I always wanted to make a game for the VCS. But maybe this was not the right time. It was all-consuming, but my all was not ready to be consumed. Finishing Brick Basher back then was simply not in the cards. That is where I stopped in December 2018. I moved away from Brick Basher, tried a few other concepts, and then quit bAtari completely, afraid to be seduced once more by the power of nuance, the power of nostalgia, and by the power of childhood dreams fulfilled that had taken me almost to the brink. I stopped until today, May 17, 2020, when I updated the game with one line of code so the ball would restart. This is the version of Brick Basher presented now on our website. There's no scoring or game end. Really, it's just an exercise in how to use sprites, the ball, the playfield, collision detection, and a little bit of math or angles for detecting hits in the playfield. You can get the demo there if you care about it. Building my first Atari VCS game demo was an amazing experience. It brought me joy I never thought possible, but also captivated me in an almost frightening way. Maybe I waited too long. Maybe I did not wait long enough. However, I'm pretty sure there will be a time in the near future when I will test the waters again, and if I'm careful, not get irrecoverably pulled under into its grasp. And thus is the danger of exploring the vertical plane.
An 8-Bit Rocket Studios production.